Hi all, I am Mithun and today I will be dealing with the basics of thermal conductivity. So before going directly to the topic, we can understand a simple process, that is making a tea. So here you can see the first process is the adding of water and boiling it. Then when it starts to boil, we add some tea powder, then sugar, etc. and boil some more and we get the final product, which is a tea. So, what is the physics involved in making a tea? The basic principle is the process of heat transfer. For the transfer of heat, we need another term, which is the thermal conductivity. So, let us see more about the topic. Yes, the physics of making a tea. Here you can see the heat transfer. As I have already mentioned, heat transfer, for the heat transfer to occur, there should be some thermal conductivity of the material. So here the material used is a utensil and the source is a gas stove. When we switch on the stove and the water inside the utensil starts boiling, it's because of the thermal conductivity. For the heat transfer to occur, there should be another term called temperature. We will be seeing the difference between heat and temperature in our later sessions. So the three major processes involved are conduction, convection and radiation. So these are three different modes of heat transfer. Yes, the difference between heat and temperature. As we all know, heat is a form of energy and it is measured in joules. And the heat produces a sensation of hotness or coldness. This is a common experience we all have seen in our day-to-day life. And coming to temperature, it measures how much hot or cold a body is. And we have different scales to measure temperature, including the Fahrenheit, Celsius and Kelvin. The Kelvin is the SI unit of temperature. Now we have to understand the two terms, that is a hot body and cold body. For that we have to take two objects and we are measuring in relative terms. A body that have more temperature related to the another object is called a hot body and the object having less temperature is called a cold body. So here you can see the image. One body is having a temperature H and other is having a temperature L. So H is at a great temperature, that is why it's seen in red, and the L temperature is less, so the body is seen in blue. The heat starts when they are brought in contact to each other. There is a conducting wall between them, and the temperature. There is a temperature difference. As a result, heat flows from one body to another. So there is a heat transfer mechanism occurring here. After some time, we can see that both the bodies reach the same temperature and there will be no net heat transfer. So we can say that they are in thermal equilibrium. And here is the first process, which is conduction. As we have seen that the copper wire conducts electricity, which means copper wire is an easy path for the flow of electric current. Similarly, there are some materials which allows the easy path for the heat transfer. So transfer of heat from one place to another by the assistance of particles but without the actual movement. So here we can see that in a matter there are certain atoms. Similarly in a material also there are many atoms involved in it. In conduction, the process is that these atoms are not actually moving but they vibrate. When they start vibrating, they began to lose energy from one atom to another. As a result, the heat is transferred. And coming to the derivation of this conduction, here you can see two metallic boxes which have gas molecules in it are placed contact to each other, having a conducting wall between them. The greater temperature is denoted by T1 and the less temperature is denoted by T2. As a result, heat flows from hot body, which is T1, to cold body T2. and let this wall have a thickness of dx and the area of the wall be A, and Q denotes the heat, and let dq denotes a small heat flowing in a small time interval dt. Let h denote the rate of heat flow, so h is equal to dq by dt. Here I have drawn a picture showing a more 3D view of the situation. So the wall has an area of A and the thickness of the wall is dx. Temperature of the hot body is T1 and the temperature of the cold body is T2. As a result, heat flows from T1 to T2. We have mentioned that H is equal to dq by dt. So if this wall has a greater area, then the heat transfer in a particular time interval will be more. Also, if you have seen that a thin metal plate becomes hot easily than a thick metal plate, so the rate of heat transfer will be inversely proportional to the thickness. That means if thickness is less, then the heat transfer will be more. If thickness is more, then the heat transfer will be less. At last, this rate of heat transfer is directly proportional to the difference in temperature. That means if the difference is 37 degree and the another situation the difference is around 40 degree, then this heat transfer occurs more in that 40 degree situation. So we can understand that this heat transfer will be directly proportional to the difference in temperature. We are combining equation 1, 2 and 3. We get the heat transfer will be equal to A into delta T, which is T1 minus T2, divided by dx, which is the thickness of the wall. In order to remove the proportionality, we add a constant called K. So K into A by dx into delta T, or T1 minus T2. Here I have taken q by t, which is similar to dq by dt. The dq by dt means a small heat transfer, while q by t means a transfer occurring in a big time interval. So here I have taken dt, here it is t, will be equal to Ka dt by dx. So I have denoted the difference in temperature as dt here, and we are rearranging the terms. We get Ka into dt by dx. Here dt means difference in temperature and dx is the thickness of the wall. This is an important term to mention, as anything divided by the distance means a gradient. So this dt by dx means a gradient. Similar to anything divided by time, we say it as a rate. So anything divided by distance can be seen as a gradient. So we can rearrange the equation as k. K is the, we know that k is a constant and it is the, k is the thermal conductivity coefficient. So we have to separate k from the rest of the equation. So we get k is equal to q by t into A into dt by dx, which is the temperature gradient. And we are applying some situation, that is when A is equal to 1 meter square, that is the area is unit cross section and the time is 1 second and the temperature gradient is 1, then K will be equal to Q. So we can define the thermal conductivity, or K, as the heat flowing through a unit area of cross section in unit time under a unit temperature gradient. I hope all of you have understood this topic. Let us move to the unit of K. It is joule divided by second into meter square into Kelvin meter raised to minus 1. So simplifying, we get joule second raised to minus 1, meter raised to minus 1, Kelvin raised to minus 1. We know that joule per second denotes power and the SI unit of power is watt. So we can finally write as watt meter raised to minus 1, Kelvin raised to minus 1. One more term we can associate with conductivity is that of resistance. So what is resistance? Conductivity involves offering a free path, but the resistance is just opposite to that, which means offering a difficult path for the flow. So electricity, we have seen in our lower classes that electric current is the flow of charges in a unit in a cross-sectional area in a time t. So we can write electric current as I equal Q by T, and by Ohm's law we can write as V by R, where V is the potential difference and R is the electrical resistance. Similarly, in heat we can mention a quantity as heat current. So if electric current is the flow of charges in a time t, then heat current can be defined as the flow of heat at a particular time t. So we have mentioned earlier that Q by T will be equal to K, which is the thermal conductivity, multiplied by A, which is the area of cross section, and which is again multiplied by dt by dx, which is the temperature gradient. So here we can rearrange it by taking dt in the numerator and the other terms, that is dx, which was already in the denominator, divided by k into a. So this dt is the temperature difference we have mentioned, and this new term, that is dx by Ka, is called the thermal resistance. So it can be compared with V by R. V means potential difference and here dt means temperature difference. R is the electrical resistance, dx by K is the thermal resistance. An important application seen is in case of insulating materials used for construction, and engineers compares the value of different insulating materials and by using this concept of thermal resistance, and finally they make constructions using the suitable materials. Yes, the next topic is convection. We have seen conduction, that in conduction there is no actual movement of particles, but they vibrate and transfer energy. But in case of convection, there is a movement of fluids or liquids. That is fluids which involves the air particles or liquids. So here you can see a utensil is kept and the gas stove is there. So when it starts to where the area near to the area which is in contact with the fire will be in a more temperature than the upper surface. So this area has a greater temperature, as a result fluids will be heated more and they start to lose their density and move upwards. On the other hand, on the surface the temperature will be less and they will be more cold compared to the lower surface and they come down. So this process continues and it leads to the formation of currents known as the convection currents. So here you can see convection is a heat transfer process involving the movement of fluids, whether liquids or gases. When a fluid is heated, the particles near the heat surface, that is near the source, become more energetic, expand and become less dense, creating an ascent. So they have a tendency to move upwards. While on the surface, the colder and denser particles then fill the vacant space, creating a continuous flow. This continuous flow creates the convection currents. And this phenomenon is there in many places, including the atmosphere, which includes the wind circulation, climate, etc. And it has numerous applications in industrial and geophysical process. For example, here you can see the movement of tectonic plates, which is caused by the similar convection current. The magma near to the core is more hotter than the magma upper it, so it begins to form a current, and these convection currents are so strong that they can even move the lithospheric plates. And here is the representation using the, if you dip two wooden blocks in a container and starts to heat, you can see that these blocks will be moving apart, or they will be moving towards each other, or they will be just passing to each other. And this forms a very important theory called the tectonic plates theory. This is the basic formula for the heat transfer, and there is no derivation. Q, which is the heat transfer volume, equal to H, which is a rate indicating the heat transfer rate, multiplied by area of the surface multiplied by the temperature difference. So here T denotes a higher temperature and T0 denotes a lower temperature, and both are measured in Kelvin. And the third process and the last process is radiation, and it is a mode of heat transfer which doesn't require any medium. So how does this radiation will occur? It occurs through electromagnetic wave. In our first semester we have studied that the electromagnetic waves carry energy and momentum. Also, they do not require any medium to travel. The best example is the microwave oven which we use to bake our food. So they are using a wave called microwave, which is in the electromagnetic spectrum. And in case of radiation, the law involved is called Stefan's law. This Kashinath has taken class, has taken the seminar, so I'm not going deep into that. By Stefan's law, the heat transfer will be directly proportional to the area and the fourth power of the absolute temperature. The temperature. Then, in order to remove the proportionality, we will be adding a constant. This is known as the Stefan's constant and is denoted by sigma. I hope all of you have understood the topics. So, in summary, we have discussed conduction, which means the transfer of energy between adjacent molecules. Here, it is important to mention that the particles are not moving. In case of convection, there is a movement of the hot fluid. Fluid can be liquid or gaseous, and this is due to the formation of convection current, which is formed by unequal heating. And at last, the process is radiation, which involves the emission of electromagnetic rays. If you keep your hand close to the source, you can feel some hotness. This can be either due to the convection of the air particles, or it can be also due to the radiation, which might be in usual cases it will be the infrared, which is also known as the heat wave. And I think our tea is ready for today, and thank you all. Drink tea and have a nice day.